Hey guys, welcome back. We're just going to do a few more examples of using the definition of a derivative to find the derivative. So, this is our function, x to the third. First step, write down f of x plus h. Everywhere you see an x, you're going to plug in x plus h. So, that looks like this. Now, I'm going to run through this algebra quickly, but basically you multiply these two out, and then you get a trinomial, and then you multiply that out, and you get times this guy here, and then you end up with f of x plus h is equal to x to the third plus 3x squared h plus 3xh squared plus h to the third, okay? So once that happens, now you can apply the definition of a derivative that says f of x plus h minus f of x over h. So, switching colors, I'm going to do limit as h approaches 0 of x to the third plus 3x squared h plus 3xh squared plus h to the third minus f of x, which is this guy here. Okay, and then after that, it's going to be divided by h. So, we know that we did it right when we see that our function canceled out, and it did. Now, those two cancel out. If you apply the h equals, h approaches 0, there's a h there, h there, h there, h there. You get 0 over 0. So what I'm going to do is I'm just going to factor out the h. You're left with 3x squared plus 3xh plus h squared over the h on the bottom. These two cancel out. You reapply, and then you get, let me highlight this, okay. Then I get this to go to 0 because there's an h in there. This goes to 0 because there's an h in there. And you're left with 3x squared. Okay, so I hope that makes sense. And so if f of x equals x to the third, then f prime of x equals 3x squared. So this is the one with the polynomial. This is the example. The next example is going to be with the function x plus 3 square rooted. First step, f of x plus h. I think that there it is. Okay, f of x plus h plus 3 all square rooted. You're just going to take the difference of the two divided by h because that's the definition of a derivative. So limit as h approaches 0 of x plus h plus 3 minus divided by, okay, we know it's going to give you 0 over 0, right? You can apply it there. I'm going to multiply top and bottom by the conjugate of this plus x plus 3. Remember, the conjugate just changes that sign. X plus h plus 3 plus square root of x plus. Now, I hope everybody was able to see my other videos. When you multiply conjugates, it's basically taking this everybody and squaring him. So this guy squared, we'll just get rid of that. This guy squared, we'll just get rid of that, and it's always going to be a minus, okay? So, or you could just FOIL it. So you're going to get x plus h plus 3 minus x plus 3. You got to be careful with that negative. Don't ever distribute the bottom, okay? Because you're going to see things cancel out. And you're going to get that. So, x cancels out with the minus x, right? Because I'm distributing. Positive 3 cancels out with the negative 3. And now you're left with h over the bottom part, okay? I'm not going to rewrite it, so that's going to be h and h. You're left with a 1. So now we're going to have the limit as h approaches 0 of 1 over x plus h plus 3 plus x plus 3. When you let this approach 0, remember, that goes out, and then you get 2 of those guys. So we get 1 over 2 of these. So that means that the derivative of the square root of x plus 3 is this guy here, okay? And then we have one more example, and then we're done. So our final example will be 1 over x plus 3. And what we're going to do here is everywhere we see an x, we're going to plug in an x plus h. Then we're going to do our definition of a derivative, f of x plus h minus f of x over h. Now, you're going to get a common denominator. You guys know I love my crisscross tomato sauce, which says 1 times x plus 3. Put that there, right? 1 times x plus 3 is itself. Negative 1 times x plus h plus 3. Put that there. And then, finally, this guy right here, you put them side by side here. That's my crisscross tomato sauce. And then divided by this h. Well, I'm going to, from this point here, I'm going to just do a little algebra. Minus x minus h minus 3. So you get x plus 3 minus x minus h minus 3. I'm going to do times 1 over h here because we're going to keep change flip. And then we're never going to multiply that bottom out. So from here, guys, I'm going to do x minus 3 minus 3. On top, I have a negative h. And then across from it, let me get blue, minus a negative h and a positive h cancels out, leaves you with a negative 1. I'm just going to put the negative there. And then I'm going to have the limit as h approaches 0 of negative 1 over x plus h plus 3 times x plus 3. This goes to 0, so you're left with 2 of those on the bottom, right? X plus 3 times x plus 3. Well, that's x plus 3 squared. So guys, these are the the 3 types of examples that we typically use for the definition of a derivative. I hope that was helpful. In our next video, I'm going to show us how to find the derivative of sine and then cosine, okay? So come back for that. I hope these are helpful.